Okay, this is our model, and here you can see the what is our problem, how to remove the multicollinearity from the system. That is our whole target that I'm trying to write here. I think it's not working properly. First I check this one, not this one. I have to come down here. Okay, the question is that how to remove the problem of multicollinearity from the model. And you can see from here we have many variables that you can see from here: y, x1, x2, x3, x4, x5, x6. So there are 7 variables, and y is the dependent variable. x1, x2, x3, x4, x5, x6 are independent variables. Okay. Now what I'm doing, I'm opening all the variables. I'm opening all the variables as a group, right? You can see all the variables. I'm opening all the variables as a group. As a group, I'm opening. So now you can see all the variables, right? And see, so these are the variables, right? So from x1, x2, x3, x4, x5, and also x6 and x7. Here we have the data. It is only 35 data. You can see 35 data, right? And y is the dependent variable, and the rest are independent variable, right? Y is dependent, and x1, x2, x3, x4, x5, x6 all are independent variable. Now we want to execute the model. So how to estimate model? I go to quick as before, and I estimate the model. I come here, right? First I put y, dependent variable, c, then x1, x2, x3, x4, x5, and also x6, right? Okay, x6, right? We have all the variables. Y is dependent, x1, x2, x3, x4, x5, x6 are independent variables, right? And sample size is 1 to 35, right? Okay, then I press OK. Okay, so this is my result. The dependent variable is y. x1, x2, x3, x4, x5, x6 are independent variable. But here, what is happening? x1, the variable is not significant because the p-value is more than 5%. Here the p-value is 68.39%, which is more than 5%. So x1 is not significant, x2 not significant, x3 also not significant, x4 also not significant. x5 is significant because the probability value is only 0.42%, which is less than 5%. So x5 is significant. What about x6? No, it is not significant because the p-value is 37.05%, and which is more than 5%, so it is not significant. Okay, you can see out of 6 variable, only one is significant, that is x5. So I can assume that, I can suspect that probably in this model the problem of multicollinearity is there. That I assume, right? Probably the problem of multicollinearity is there, and that is why only one variable has become significant, right? Because of the problem of multicollinearity. Okay. Sorry. Now the question is that how to detect the multicollinearity, right? Okay, that is the questions. That is how to detect the multicollinearity. How to detect the multicollinearity in the model. In the model estimated below, right? That is the questions. How to detect the multicollinearity in the model estimated below. Okay, how to detect? So we have to go to the correlation analysis, right? That we have to do to check whether, we have to do the correlation analysis to check whether the independent variables are highly correlated or not. And if the independent variables are highly correlated, meaning that there is a problem of multicollinearity. Okay, so what is the effect of multicollinearity? Okay, what is the effect? It comes up again. What is the consequence of multicollinearity, right? What is the consequence? Okay, so suppose this multicollinearity makes the standard error big. Okay, the question is that how to get this t value. T value means, suppose I talk about this one. T value means this, the coefficient divided by standard error. I can get the t value all the time, or t statistics. What about this one? This one means 876.42 divided by 3796. So I get this value. This is t statistics. Okay, and what is the t value and p value, and what is their associationship? Okay, normally, not normally, it always happen. The t value and p value always has a negative associationship all the time. If the t value goes up, p value goes down, or absolute t value goes down, p value goes up. So they have always opposite associationship all the time. I said absolute t value, not only t value, meaning that absolute means there is no sign. Absolute means there is no sign, right? All are positive, absolute. So here you see this p-value is very small, and that is why the t-value is so big, right? You can see from here, right? T is so big, so p is so small, right? So there exists a opposite association shape. And also here, the t value, that means absolute t value, there is no sign, right? That means we should ignore the sign because I'm telling absolute t value. You can see from here the t value is big, 1.92, so p value is small, 0.06, right? So that means the absolute value of this column and this column has a opposite association shape all the time. Okay, now what is happening, what really happens, suppose, what is the consequence of multicollinearity? Okay, and if there is a multicollinearity, then the standard error, this one, this value goes up. This value goes up if there is a problem of multicollinearity. This value goes up artificially, right? If there is a problem of multicollinearity, the standard error goes up. And if the standard error goes up, then t value goes down, right? T value goes down. Why? Because this divided by this value actually we can get. So if this one goes up, meaning that this one goes down, and if this one goes down, then p value goes up. And if the p value goes up, that variable becomes non-significant. That variable becomes insignificant. But actually, maybe x2 is a significant, but because of the problem of multicollinearity, it becomes insignificant, right? Okay. And also it is the same story here, x4. If there is a problem of multicollinearity, x4, the standard error goes up. If the standard error goes up artificially, then t statistics goes down. As a result, p value goes up. As a result, that variable cannot become significant in this model. Okay, then comes up how to detect multicollinearity now. How to detect multicollinearity, right? So how to detect? We have to do the correlation analysis among the independent variable only. Among independent, don't bring dependent variable here. Independent variables, right? Among independent variables only. Don't bring dependent variable, right? Okay, so I have to go to quick, then group statistics, then correlations, right? We have to check correlations. Okay, then I put, okay, here all the variables I drop y. I can drop y because y is the dependent variable, so I should drop y, and also the constant, the c I should drop also. So these are all independent variables, right? So I run the model. Okay, this is my result of correlation coefficient. Yes, that you can see. This is the result, right? The correlation coefficient. I make it big. Okay, so suppose this one is the correlation coefficient between x1 x2, and suppose I talk about this one is the correlation coefficient between x4 x5 and so on. Okay, now the question is that which one has the highest correlation coefficient from this correlation analysis. So from here I can see that yes, this one, right? This one, meaning that the correlation coefficient between x3 and x4 is the highest. How much? 95.36%. And because of this high correlation coefficient, the problem of multicollinearity has arisen, right? So I'm telling again, because the correlation between x3 and x4 is very high, 95.36%, and that is why the problem of multicollinearity has arisen, and that is why most of the variables have become insignificant. So now how to solve the problem? Okay, now out of x3 and x4 I must drop one variable. That is the guideline. That is the guideline to solve this problem. Either x3 or x4, that I must drop. But the question is that which one I should drop, x3 or x4. Okay, what is the guideline? The guideline is that out of x3 and x4, which has higher p-value, that one I should drop. I am telling again, out of x3 and x4, which has higher p-value, that I should drop. Okay, what does mean by higher p-value? Higher I'm writing here, the p-value, lower the level of significance all the time. Lower the level of significance. I'm writing here, higher the p-value, lower the level of significance all the time. So that is the all the time. So now we can check our model that which has higher p-value. Now we can check our estimated model. Now we can check our estimated model that we have just done, that we have just estimated, right? That we can check now, right? Now we can check our estimated model that we have just estimated. Okay, our model is which one? It is here. Model is here. Oh, sorry, the model is here. that we have just yes, this is the model that we have just estimated. Okay, out of x3 and x4, you can see x3 p-value is 0.06 and x4 p-value is 0.30. That means x3 has x4 has lower level of significance, because if the p-value goes down, that means the level of significance goes up, and when the p-value goes up, the level of significance goes up, right? So normally if the p-value is less than 5%, meaning that that variable can influence the dependent variable, right? If the p-value is less than 5%, meaning that that variable can influence y. What is y? Dependent variable. That means if the p-value is less than 5%, then that independent variable has a influence on the dependent variable, which is y. So meaning that out of x3, x4, also we can say that in other way, x4 is far away from y, and x3 it is nearer to y, because the p-value is small, right? So now we shall drop x4, and we shall estimate the model again. That means what I want to do now, we shall drop x4 and run the model again, right? Okay, so that we shall do now. Okay, I go to quick estimate equation, right? Okay, then I put y c x1, x2, x3, x5, not x4, right? Okay, so this is my new model after dropping x4, right? So now now I press OK. You see there is no x4 here, right? So I go to OK. Okay, so this is my new model, and y is the dependent variable, and these are all independent variables, right? You can see from here, and here is no x4. Okay, now you can see x1, it is not significant, right? x2, no, not significant. But x3, yes, it is significant at 4.89%. X3 is significant at 4.89%. That means which is less than 5%. And x5 is significant at 0.05%, which is significant. And x6 is significant at 3.58%, meaning that less than 5%. Now you can see, now the three variables have become significant out of 5 independent variables. Last time only one variable was significant, but now 3 variables have become significant because the problem of multicollinearity has been removed. That is why more independent variables have become significant. And the question is that what is the guideline? Guideline of a good model. The guideline is most of the independent variable should be significant. Then we can say a particular model is a good model.